Welcome to another episode of Computer Vision Decoded, where we dive into the complex and quickly evolving world of computer vision. And today I have, of course, my co-host Jared Heinley, a PhD in computer science and knows lots about 3D reconstruction. But today we're going to dive into something that crosses over that we all need to make something into 3D. That's a camera. So today's the camera episode. And I'm really excited because, well, Jared has a lot of technical information about how like distortion in cameras work and how they work together. I spent a lot of time, or have spent a lot of time in my career in the field using different cameras that he's built algorithms to reconstruct 3D environments off of. So we kind of have different backgrounds, different perspectives. And at the end of this, the goal is we will go through different types of cameras, starting with a kind of a consumer-based camera up through a more professional, and then maybe even think specialized cameras. And we won't spend as much time on those because less people use them. But to give you an appreciation of what's the difference and maybe which one's the best for you, I can tell you there's no right camera for anyone. Would you say that's true, Jared?
That's true. That's true.
So, well, anyways, well, welcome, Jared. Thanks for joining me on another episode. I'm really excited about this one because we keep talking about things I think people can take home and use and try to implement in their work. And we kind of gloss over the camera, and it all kind of starts there.
Yeah.
And I think a lot of choices that you use in reconstructing a scene from 3D, be it a mesh with textures, be it point clouds or SLAM even, the camera can really dictate what you can get away with and how easy it is to process the data.
Yeah. So. Yeah, totally. It is a key piece in the process. The thing that's actually capturing that imagery.
So, all right, let's jump into this. So the format I'm going to do is I'm going to start out with a type of camera, and then we're going to talk about what's the strengths, what are some of the drawbacks of using that camera, and then what would then be that camera useful for. And it can be kind of limiting. Say this camera is only good for certain things or things like that. I would say even if you only had a smartphone, which we'll start out with, you pretty much do most of the things we're going to bring up in this episode. Just there'll be some drawbacks to using it versus some other cameras. So, Jared, let's start with the smartphone. I just want to say, like, what to you, off the top of your mind, what is the best strengths of using a smartphone-based camera?
Oh man, well, it's always there with you.
Yeah,
I mean, it's just it's so. Form factor's great. You can put it in your pocket. It's always there right with you, and because it's a consumer device, camera manufacturers, smartphone manufacturers spend a lot of time making those photos look nice.
Mm-hmm.
And so you want a good looking photo, you don't have to fiddle around with a lot of settings to get a good looking photo. So
true. At this point, it's less about what's the right button and more about composition on the smartphone, and it will figure it out for you. It'll even know. I'll take a picture of my dog, and it'll recognize it's an animal, and it will put it in a portrait mode for animals to better accentuate like the hair on it. I didn't tell it what to do. It's using machine learning in the background.
It's so much. There's so much. And I think we might have touched on this in previous episodes, but talking about computational photography, like you said, there's so much machine learning happening there. Image processing. You take photos of your dog. I take photos of the food I make. It's like, wow, that photo looks better than the food sitting there in front of me. It's accentuated and high added. That color or some of the contrast, and brings out some of the detail and things, and really makes it stand out.
Yeah, I'd say some other pros to using this camera. Or a camera on your, let's say I have an iPhone, so I have 3 different cameras. So that's the great thing is I got a wide, I have a telephoto, and I have they call it normal. I think it's still wide. There's a wide and ultra wide,
ultra wide, yeah,
and telephoto lens, and they're all prime lenses. So when you're zooming on these, you're not actually physically you're not like changing the optics and changing the focal length of the camera. Is that correct? We're more switching
Correct.
Which camera is being used. I know they're doing some other tricks, like there's like a 2x, which is using the quad sensor.
It's like a cropped portion of the sensor. But yes, that's what when you're zooming on smartphones, it's not actually moving the lens elements. It's just changing which part of the image it's cropped.
So then this is going to cross over into the other cameras too. What is the importance of using a prime lens, which these are?
A nice benefit of a prime lens for purposes of computer vision, because that's what we're talking about here. As I will say, it's nice because that it gives you more consistent focal length. And so if all of your photos are taken from the same focal length, there's some benefit to the reconstruction settings, the reconstruction process. When you go and try to solve for all of the poses, the position and orientation of those images around your 3D scene, if all of your images have the same focal length, well then you can add that as a constraint in the bundle adjuster, and the thing that's actually refining the positions and orientations of the images as well as the points in the scene. And
Okay.
so that's having a consistent focal length or a consistent camera, that's taken all those images is quite nice.
And so a smartphone, let's say, I think you maybe have a Samsung. I have an iPhone.
Yep.
When you take a photo, does it save that information about which like lens and all those different they're called intrinsics, right? Of each image. Are those saved in each photo you take?
It is to varying degrees. So, like when I take a photo or you take a photo, there is EXIF data, EXIF, which is the standard metadata. It's a key value pairs typically, but standard metadata associated with your photo. And so we'll say, oh, this was taken with a focal length of 3 millimeters, but in a 35 millimeter format. Oh, that was a 20 millimeter lens or something. So it will tell you information about the focal length that was used. It'll tell you the shutter speed, the ISO, so like the sensitivity of the sensor that was used, and it gives you some other standard attributes telling you about what were some of the basic settings that went into capturing that photo.
Okay, so it does give you some. I think I think we'll bring up some of the enterprise kind of drones. There's some things they have in there that's beyond that you get.
Yep.
But
Yep.
as for an iPhone, you get some basics. So I do know though, when you take a video and let's say you zoom in with a video, I don't even know if in videos in general, they give you they tell you shutter speed, things like that. But that might even be variable. Things get more complicated.
Yeah, because again, my understanding is some of it's just limitations of the file format, like the JPG file format, or Apple uses HEIC, high efficiency image codec, for some of their photos. Built into that format is this notion of metadata, where you can associate all of the make, the model, the focal length, all these things we just talked about that went into capturing the photo. For video, there's not. At least my understanding is there's not quite that same standard to say that, oh, here's how you associate metadata with your video. I think when you're in the Apple ecosystem, Apple does some tricks and says, oh yeah, you've recorded a video, we're going to store metadata along with that video, either in a separate file or in the database, so that when you're viewing that Apple video on another Apple device, you can get some metadata. But then, like when I take a video with my Android, Samsung phone, share it with you, it just looks like a video. You're not getting all of that. That metadata is not necessarily transmitted or contained within that video file. And so, there is some limitations and trade-offs there.
Yeah, and I know you have to be careful when there's all these special modes now they put in. So that's, I guess, one weakness is there is some finicky little things. So, like, if I take a photo with an iPhone, it does a live photo, or it does just a photo or a raw photo. So there's like different options, and the live one is like taking a little video and then probably doing compositing, trying to pick the best image out of that. So if I go to download those on my computer and I bring up File Explorer, it's going to show me all these little video snippets and not just the photo. So you have to be careful with that. And then the RAW, I know there's RAW, which is from an Apple phone, is great. You're getting like the full sensor. Color might not be what you're used to because they use like an Apple Pro RAW. So if you're trying to get if you are a professional in photogrammetry, RAW matters to you because you're trying to get these textures and everything to look good. You're trying to expose information and the darks and the lights that might be lost. And so, can you tell us what that is? What is a RAW photo? How that helps you get that information?
Yeah, because that raw photo typically has the raw information. So, when you capture a photo, a lot of times that sensor may be recording a greater amount of information that can be stored in a JPEG file. So, like for example, typically in JPEG, There's all sorts of compression that's going on. But like one standard technique is to say that no, I only have 8 bits per pixel, 8 bits, so a value between 0 and 255. And so, oh, what is the brightness? How much red is in this pixel? 0 to 255. That's all that you get. And so there's only 256 unique values for the brightness of the red or the green or the blue. Now it gets even more complex because JPEG separates the luma from the chroma, so like the brightness from the color, and each of those are compressed separately, and so you even lose more information. So to go to a file format like JPEG or even HEIC, you are losing information. And so RAW tries to preserve that. And so it's going to give you more than 8 bits per pixel. You might have 10 bits per pixel. So that would be like 1,024 unique different values for the brightness of the red, the green, and the blue. RAW a lot of times can also give you more information about how the photo was captured. Now I haven't dug into Apple's raw photo, file format, but like each camera manufacturer may have their own format. I know there is some standard formats like DNG. I think it's Adobe DNG. When I haven't used it in a long time, but I used to have a Canon DSLR, and so it would save its own Canon RAW file format. It was like a CR2 or something.
Oh yes.
But like each camera manufacturer has their own potential RAW file format that's going to contain as much information from the sensor as well as like the metadata that the camera was aware of when it captured that, so that you can take all of that data and figure out afterward, how do I best want to process that information to go after what I'm trying to process or trying to accomplish.
I think they're interesting because if you are in a high dynamic range scene, especially I think like outdoors, or maybe, I don't know, someone recently posted their post-processing of raw imagery inside a cathedral where you have lots of shadows and lots of bright light coming through these big stained glass windows, and up in the giant flying buttress rafters, they're able to pull all this detail out that they didn't get in a JPEG, which was really cool because then they were able to get a much more detailed and accurate photogrammetry output. However, it's like I knew you have to be careful with that because not all software can take every single raw type of image. You need to know what you're doing. Usually you're doing then something in Photoshop, and just make sure if you do some adjustments, you got to adjust every photo to be able to match, or else you're going to have these mismatches. If you're just trying to get probably raw geometry, like a point cloud, it might not matter. But if you're trying to get textures or in a Gaussian splats, if you have if an area goes from light to dark, you get what's called these kind of like floating apparitions because it doesn't know exactly what's supposed to be there, or things kind of like pop into different colors and you're like, oh, what's going on there? Well, for one view it's supposed to be brown, for the other view it's supposed to be light brown, so it doesn't know what it's supposed to be. You run into those kind of issues. I do know someone who told me once, it's like, do you do a global adjustment when you're doing things to raw? And they said, no, what I try to do is find like a bunch of groups of pictures will taken from a similar area, and then you'll do a global adjustment to all those, and then the next one you might have where it's a little darker but of some of the same area, so it's like, okay, I need to adjust those to match the other batch. So you can do batches, but you don't necessarily need to adjust every image all at once, because sometimes a photo was taken in a darker part of a room or something like that, where it's then done some compensation in the camera itself. So at that point, you probably know what you're doing with the raw photo.
Yeah.
So
I didn't even think about that, because I imagine that then opens the door now, because this is moving beyond computer vision, but like the artistic side of it. It's like if you were trying to document the interior of a cathedral where one side of the cathedral is much darker than the other. It's like, well, what is your desired goal? In your final 3D model, do you want to represent that and see that, wow, when I look at this model, this mesh, this Gaussian splat, whatever it may be, this half of the cathedral is much darker than the other? Or are you trying to achieve a consistently illuminated result where it just all looks equally illuminated?
I think if I was preserving it for like architectural preservation, I'd want it to be globally illuminated. And then later, if you were doing it as an artistic output, there's all these illumination options within software. You can add lighting and things like that. But yeah, you're right. Depends what you're trying to do. Are you trying to reconstruct it for an art piece? You probably want it as is, or so you have options. So I'd say if you're on a smartphone and you're trying to run around with raw photography, you're probably using the wrong camera. You should probably be using more of a mirrorless, or we'll get to that. That'll be next, or a DSLR. I don't know if those are popular anymore. I think Sony kind of replace those for the most part for every camera manufacturer. But
Yeah.
okay, so then the weaknesses as we were kind of talking about, you don't have the best control. There are some third-party apps that you can have on these that let you control it a little bit more, and there's some control within each, native software for cameras, but you're not controlling not manipulating like a focus ring or anything like you got with a nicer camera. Not always the best in low light. And
Yep.
why is that? Well, can you explain why that wouldn't work so well?
It's just to physics and being able to capture photons, capturing light. And it comes down to, because in a smartphone, the physical size of the camera sensor, so the thing sitting behind that lens, in a smartphone, that sensor is pretty small. It's millimeters. And in low light conditions, there's not a lot of light. There's not a lot of photons bouncing around. And so typically, in order to do well in low light, you want to make your sensor as big as possible so that you can capture all of those photons and still make sense of what the scene looks like. But when your sensor is only so big and it's really small, you're not capturing as many photons, and so you're going to end up with a noisier image because there's not enough signal. Your signal to noise ratio is out of whack. There's not enough signal, not enough real photons hitting that thing.
So like if you mentioned ISO. So ISO is the thing that will, like, if you push it up, it'll brighten your image. But you also then expose more noise in it, right?
Yeah.
So you get these like little
Because you're just multiplying. You're like, hey, whatever photons I am seeing, let me just multiply it. So anytime I receive 1, let me pretend that was 2. Or anytime I receive 2, let me pretend that was 4. So you're just multiplying, that signal that comes in. But yeah, that native sensor itself, is not. You put your sensor in a dark room, it's not outputting a perfectly black image. It's thermal noise. There's just you get just slight noise in the image that then is always there. And so you typically want to you want to have enough real light to overwhelm just the native noise that's present there in the sensor.
Yeah, that makes sense. Which we'll get to sensor sizes a little bit later, but so they're just small on these. So
yeah,
I've seen some of these crazy ones now coming out. I think like Xiaomi has one that they put like a 1-inch sensor on it, and the back is like this ring on my phone. If you're watching the YouTube version of this video, I have this ring on my Apple case where you can charge, but that's like the size of the camera, but it's still not gonna approach the quality of a several $1,000, professional camera. You just can't.
Yeah.
And then also, I think they do a lot of lying in the literature on some of these cameras because, for example, there's a 48 megapixel camera sensor on this iPhone 16 Pro. And I think some of the Samsungs I think they've reeled them back, but some were 200 megapixels, 100 megapixels. Then that means your the size of each pixel is got to be like microscopic. So
tiny.
The difference, so they're having to do tricks. So they use what they're called like a Bayer quad filter, or what's it called? So they're doing tricks.
Pixel binning.
Binning, right?
Yep.
So they're taking like the average of 4 pixels to make 1 pixel.
Yeah.
So if you're thinking you're buying a 48 megapixel camera, you are technically, but I'm getting 12 megapixel photos out of here. I can get a raw 48 megapixel image out of it, but then again, I'm going from a like 4 megabyte file, or I can't remember what they are off an iPhone, to like a 50 megabyte file. So, be careful there too. You're going to have lots of room on your phone.
Yeah.
When you start running around taking photos, and raw video is even worse. I mean, yeah. So, all right. So then given all these weaknesses and the fact that it fits in your pocket, which is kind of the big benefit to an iPhone, and it's I'd say it's user friendly, right? You don't have to become an expert. You have one, you probably already know how to use it pretty well. What are these good for? What do you like these for, Jared?
I mean, I like the smartphone again because you said it's portable, easy to work with, programmable. As a computer vision researcher and also just a software developer, it's nice being able to write software that can run on the iPhone itself and have that direct, quick feedback from the camera. So that enables applications like augmented reality or real-time 3D reconstruction, where someone doesn't have to go out to take a bunch of photos, offload it from the camera, import it onto their laptop, or upload it to the cloud. It's like, no, that you can do processing right on those images as they're coming in to accomplish some task, either guiding the user through a capture or showing them the results in real time. It's nice having the processor and the camera in one piece and being able to write code for that.
Yeah, I like to think you're not buying just a camera. Well, I mean, obviously, or a phone. You're more than anything, you're buying a computer, a really good computer that fits in your pocket.
Yeah.
So you can build apps on it, like you said.
Yeah.
And it's packed full of sensors.
Yeah.
Which you can tap into. So this one has a LiDAR or a structured, I don't know if it's a true LiDAR, but it's got a LiDAR, a depth sensor on there.
Yep.
It's got two, one on each side for each camera.
Yep.
It's got 3 cameras. It's got an inertial sensor, so it knows if it's like turning or pivoting. It's got a GPS on there. So you start to think how many sensors are in this tiny phone. It's incredible. So you, Jared, being a developer, can leverage those through APIs right from Apple, or there's ARCore for Android, and then speed up reconstruction, right? Because now you already have a good idea, perhaps, of where that phone went as a trajectory and where the photos were taken, and you can probably speed up that reconstruction process quite a bit.
Yep, exactly. And so, and that general concept is applicable to other metadata as well. Like you say, your drone, has GPS position, or if you had photos that were geotagged and had that GPS embedded in the EXIF, there's ways to use that as a constraint to help accelerate, 3D reconstruction. But then, even more so with all those inertial sensors you just described, and whether you're using a SLAM system, the on-device pose tracking system like ARKit or ARCore, those pose estimates can be used to accelerate 3D reconstruction process.
Yeah, and you get depths with your photos, things like that. That can just speed
Yeah.
things up. So
Yeah.
these are great. I've been doing lots of Gaussian splatting, and of course, we all know that. My favorite app for that on this, I don't like to necessarily promote one app, but there's only one app that does it on device, and it's Scaniverse. And you can go out and you can create 3D reconstruction, or you can do a Gaussian splat right here on the phone. It takes like a minute to process, and you can actually hit process over and over and get it better and better. There's more rounds, and so then you can like learn how to make good captures without having to then go upload the images to a service and waiting, or it's just you find out right there and you can go try it again. Same for photogrammetry. I think the iPhone now supports it, where you can do photogrammetry right on the iPhone with their own object capture. So there's just, you can do lightweight computing on the phone, which is really cool. And you can go through trial and errors before having to go sit at a PC or upload it to a cloud, which is big. And like we power Recon 3D at every point, and you're doing detailed 3D reconstruction in a point clouds right on the device as well if you need to, for safety and like data safety. You don't want that data to leave a device. Well, there you go. So you have a decent computing platform. All right, so I feel like we've talked iPhone and smartphones, I guess, pretty well. I think that's because everyone at least has one. Start there. If you're learning 3D reconstruction, I would start there. You don't have to figure out lenses or
it's a no-brainer.
Flying a drone camera at the same time, taking pictures. So let's then move to I had camera props, but I don't have a DSLR on my desk just because I'm using it as my camera here, but I do have some lenses. I have some interesting lenses. So
nice.
Let's talk about that. So I say the biggest strength already to a mirrorless is the fact I have 2 lenses here. I have a prime lens, and I have this is a fisheye lens. And so you can it's like there's no limit to the number of lenses. Well, there's a limit, but it's usually price. But you can mix and match lenses on a mirrorless camera with or a DSLR, because they're detachable for the most part. There's some that are come like all in one. But Jared, what else would you think is a big pro to using one of these cameras?
Oh, well, the DSLR. I mean, like, to contrast the smartphone, typically, your DSLR is going to have a much bigger sensor. And I'll say DSLR/mirrorless. Maybe we're grouping theirs, but just in this class of camera, you've got a bigger sensor. so you'd have better low light performance. I like you're touching on the lenses, so you can swap out the lenses. So it's the same sensor, just different lenses compared to the phone, where it was, oh, I've got 3 cameras, which means I have 3 lenses and 3 separate sensors. But now it's one sensor that then can be adapted to capture different types of photographs based on that lens. Typically, also, now that my sensor's bigger and I've got these big lenses, now it can hurt 3D reconstruction and hurt photogrammetry, but for artistic side of things, you can have more control over your depth of field, and so you can blur out the background easier when you actually have a sensor that's bigger. Because in order to blur out your background or blur out the foreground and really have a sharp plane of focus where everything else is blurry, you just need a big sensor and big lens. And so that's just something that's only really accomplished with that DSLR sized thing.
Yeah. So I want to take that line of focal plane as well. So a term I've thrown out in tutorial videos and just my tech evangelism is when you are capturing scenes for 3D Gaussian splatting. A big pro of that is that it doesn't recreate just the object in front of you. It's going to recreate the entirety of the scene that you capture. And therefore, I always tell people, you want as deep a focal plane as possible. You want everything to be as sharp as can be. Because even in like game engines, you can render this and then bokeh the background digitally. Yep. You don't have to actually do it in capture, but if it's not focused to start, it will never ever be in focus later. And so, like I was playing around with this one. This camera is a fisheye lens, so it's hard to see in the picture, but it's like a bubble almost, and you get this 180 degree. It's not this like the circular, but it's I forget the name of it. It's been like it's a really wide capture, but it fits just a normal rectangle in the end. And it's really easy to get everything in focus because it's got what's called there's a hyperfocal point. Can you tell us what that means? Like, because I've had a hard time explaining to people.
Man.
Hyper. Do you even remember that from your days?
The hyperfocal distance.
Yeah,
I think it's okay. I don't quote me on this. I'm sure go look it up online. Go ask ChatGPT. But I think it's a measure. Typically, it's like when you have a lens, you can look up what's the hyperfocal distance, and it's the point at which, like, oh, if I focus on 5 meters away, it's like at that point, everything is going to be essentially in focus. It's kind of telling you, I think, at what distance does all of a sudden everything look like it's in focus, or at what point, which setting should you set to maximize the clarity of your entire scene, across all depths.
It's kind of like when you take those landscape photos. Yeah, exactly. The same thing you're saying. The camera is like the landscape symbol or the infinity symbol saying like, hey, if everything's far away, it's all going to be sharp.
Yeah.
But if you have like one thing in front of you, it'll probably focus on that and then it'll be like invert. So I always tell people, if you can do that and like get far enough away from the objects that it all is in hyperfocal range, it's going to look a lot better than if you try to have like something close in the foreground. It wants to either make that blurred out or all in focus in the background blurred out.
Absolutely.
There's something to do with like this fisheye lens where I think the hyperfocal distance is like a couple feet from you. So unless you're like right in front of something, it's all going to be exposed or, within the same focus.
Yeah. Because that depth of focus, like what amount of the scene is in focus, changes. I'm operating side. If my camera is on one, now you can't see this if you're on the podcast, but I guess what I'm trying to say, I'll do it verbally then. Is if I'm focusing on something a foot away from me, it may only be plus minus a half of an inch that's in focus. But then if I focus on something 10 feet away from me, it might be plus minus 6 inches or plus minus a foot. So it's like the farther away you are focusing on something, the greater range of things, in a real distance that will be in focus. And so when you're focusing on something a mile away, all of a sudden it's like, well, wow, now everything's in focus, because that depth of focus has now increased to encapsulate or capture your entire scene. So
It's kind of a term that people don't run into, but they probably intuitively know that, like, if you're far away from everything, things can all snap into focus. But
yep,
it is, you can look that up for your camera, and it'll, for that lens,
yep,
what that distance is, that if everything is beyond this distance, it's all going to be in that range then.
yep.
And to me, that's a really helpful tool if you're trying to get the whole scene in focus. And I've also noticed, even in photogrammetry, where I don't care about the background, but sometimes the background is something for it to track over time in images. And so
Yes.
having that somewhat in focus too will help. Sky doesn't really help, but maybe there's some buildings or something in the background with unique geometry that you can track. And so if you watched our last episode, we kind of talked about that. It's like, you have these unique different patterns and features that we want to capture as we go along.
Yep. Yep.
I've even seen that when people will try to put like an object on a turntable, or opposite, put an object in a room, and they walk around and they're trying to just do the object. And the background is like all white walls or something. They're like, I'm not getting it to work. And I realize, well, the object itself doesn't have a lot of unique features, nor does the background. So I've now been paying attention when people are showing these volumetric captures. I notice they have not just the camera rays, because all the cameras are the same. They have, let's say, 50 of the exact same camera. Well, that's not very unique. But what they'll do is they'll have a bunch of April tags, which look like, if you're listening, it looks like a bunch of QR codes, and they have unique ones all around the inside of the capture rig. So it is giving it something unique to register between the cameras. And it's like, oh, that's smart. Because the thing in the middle, especially if that's moving, like they're trying to do a video, things like that, that thing in the middle might be moving. So they need the background to be unique, but a bunch of cameras aren't very unique when they're all the same, at least. So,
Yep.
So I know we get in the weeds here, but they're really useful because you have really big sensors. So bigger dynamic range. So that means you can get more brights and darknesses in one shot. You can there's all these raw options. There's all these different profiles you can put on them after the fact to like correct, to get them nice and exposed through different software. The lenses are great. I really like these high distortion fisheye lenses, as I'm starting to see some of this reconstruction technology come out that actually supports it. But why wouldn't I be able just to run around and just use one of these, Jared? These, like, why does distortion matter? And why does that break things down? Whoops.
Yeah. It makes it harder for the reconstruction algorithms a lot of times, because a lot of times in a 3D reconstruction, we use a technique called the pinhole camera model, which treats the camera as a single point in space, and then every pixel in the image is just a ray, so a line segment, but I call it a ray because it can go out into infinity. So it starts at that little point, that pinhole, and then shoots out through the pixel of the image, and then goes out to infinity. And that's just a straight line the whole way. And so that geometry is really easy to model. Going from one pixel to the next, it's just straight lines in slightly different directions. Where distortion becomes problematic is now when I go from pixel to pixel, it's no longer just the same straight line. It's, oh, well, this pixel is actually shifted a little bit in a different direction, and so especially when you have that wide, like that fisheye lens, those pixels along the edge of the image, they've been bent to look in very different directions. Now you can still try to model and say, no, my light's coming in from this direction and it hits my sensor, but now there's not the same grid of uniformity that a lens without distortion would have provided. Because when there's no distortion, I have this nice grid of just X and Y. It's really easy for me to figure out which way the rays are pointing. But when there's that distortion, now all of a sudden the reconstruction algorithms need to understand that, because it needs to understand that mapping between camera position and the color that it's seeing in these different ray directions.
So you need I've seen you do it. You've calibrated these lenses and you can get the distortion, like probably some sort of mathematical model to try to describe the distortion along the different XY coordinates of a picture on that lens. So
yep.
Towards the edges, you'll see it. It's like warped. And then towards the middle, things look, I don't know, I think of like I'm from cartography. Think of like a map projection where our Antarctica can look huge or small depending on how it's distorted. Same with an image, right? It'll
Yeah.
stretch. Even if you put the ultra wide on these smartphones and take a picture, you'll sometimes notice someone's people's like their feet and their legs and their the top of the screen, things are like just a little bigger than they should, and it's
Yep.
just distorting the edges of the camera. All right, so I want to keep moving this along because there's several cameras I still want to talk about. I say the biggest weakness to these is that there's a learning curve, right? So you got to learn how to use you got to learn the exposure triangle properly. You got to learn how to use your camera lens. You can put everything in auto, but I suggest kind of learning some of those different modes within a camera. I'd say another big weakness, if you're taking video and running around with it, a lot of them have what's called rolling shutter, which I think we'll talk about with the drone because that's where it really applies. But like, for example, the one I have here, if I'm moving, Sony is got a really slow sensor readout on this model. I know if you have a very expensive mirrorless or DSLR, it might have a mechanical shutter, which again we'll talk about. But I get it's like if you ever take a picture of you'll see these pictures of like propellers and they look like they're bent. That's rolling shutter. So it's reading out the image sensor as something's moving and it'll warp it. And that's a no-go. That's not good for photogrammetry. I've used software that'll say, it can compensate for that, but it's never as good as just getting an unwarped good image. So I'd say that's a big drawback, is that some of these have big sensors with slow readouts, and if you're trying to move while you're taking photos, it's not going to be ideal.
Yeah, yeah. I like how you summarized it. Like the big sensor has better capabilities, more options, but that's that learning curve.
Mm-hmm.
There's more opportunity for you to end up with a bad result.
Yes. You can almost magnify the errors in those.
Yep.
But I think what they're good for is professional work. If you're getting paid for some of this 3D reconstruction, you're trying to make a beautiful architectural preservation or progress photos for some construction thing, and you're trying to reconstruct it, and you want it to look as good as possible and be able to work with that dynamic range being outside or inside, it's your best option.
Yep.
But if you're at that point, my hunch is that you're already used those cameras and you're already on that learning curve towards I know how to use it really well.
Yeah.
And there's a lot of people out there. I think I spend time on LinkedIn. There's some people on LinkedIn that are just incredibly knowledgeable, and I guarantee if you reach out and you ask them a question or two, they'll point you in the right direction towards settings for specific cameras and things like that.
Yeah.
So, and we don't really use them much at work. Just we're out there reconstructing images fast or scenes fast. So, these are slow, not fast. So, all right.
Yep.
So I'm going to move on. This one I'm not going to talk too long on, but action cameras, because I've seen some really cool reconstructions of action cameras. So think GoPro or Insta360. I don't have one of those on my desk. I don't have a prop, but I do have a couple. Right off the bat, I'd say like the big pros of those, again, they have these big wide field of views, which is great. So you can capture a lot in one image, but also they're really easy to like attach to things. I can attach them to a car. I can attach them to a robot. I can attach them to myself and use them as like an what do you call it? It's like just always there capturing things for you if you want. And I think another big cool one about GoPros, they have an open API, so I can control up to I forgot how many. You can control like 100 GoPros with an API through awesome. A low energy Bluetooth connection thing or whatever it is. They have different, think through Wi-Fi, and through low energy Bluetooth is less cameras. But the fact that I could get, let's say, 50 GoPro cameras all capturing images or video in all time synced through an API is a big deal. So there's a lot of reasons why these cameras are useful, but like, to me, what's the biggest drawback? Then why don't we all just run around with the GoPro?
Yeah, I mean, I was going to say, too, just with that wide field of view, a lot of times that comes with the distortion like we just talked about, with that fisheye lens. Because a lot of times in action photography, action videos, sports videos, you want to see that wide field of view. You want to see wherever that person is operating. Because, again, like you said, it's you might just set this up to capture and just record whatever, you're seeing, and a lot of times with wide field of view comes distortion. And so that is a downside for 3D reconstruction.
But But Jared, I just clicked the button to undistort it all. Problem solved.
Problem solved. Yeah.
Or problem created.
Yeah, both. Like it can help. So that again is the camera's inbuilt lens undistortion. So it depending on what it is, it most likely just has some hard coded undistortion parameters. So it says the camera manufacturer knows that most of their lenses have a certain amount of distortion in them, and so it can just do some math and map those pixels to make it look like there's distortions. Now, by undistorting it, a lot of times, you'll lose some of that field of view. It's going to crop off some of those outermost pixels that would have been highly curved or distorted. You can also introduce weird artifacts where if that manufacturer's undistortion formula doesn't exactly match reality, well, now you're going to be warping the pixels in yet a different way. And so you may get close, undistort the pictures, but now there may be some other kinds of weird distortion in there, where pixels have been slightly shifted, based on a sort of a nice grid mapping. Some may be shifted left and right and up and down and stretched and squashed in subtle ways. Like now to a human, the photo looks great, but to that 3D reconstruction algorithm, which is trying to get pixel perfect alignment and estimation of the parameters, it can sometimes complicate that.
I know there's more than one way to stabilize an image with software, and some are more destructive than others. Like the basic just cropping and trying to keep it all like closer and keep that shake.
Like motion stabilization. Talking about image stabilization techniques, because then that's going to change what part of the sensor it's cropped from. And now you're moving over pixels that came from different parts of that lens, and so there's different amounts of distortion in different parts of that lens, and there's a lot of weird effects, and especially when you throw in what I like you brought up before about the rolling shutter, and reading across those pixels out at different points in time across the sensor. Now just throws even more variables into the mix.
And I tend to find these aren't the best. Again, they're just like an iPhone, or sorry, I keep saying iPhone because that's what I have, but a smartphone. They don't have the greatest dynamic range. I know they're getting better and better, just like a smartphone. A lot of that's kept up as well. But they're highly distorted. They're just easy to put a lot up. And if you're trying to do an array and you're not going to be moving around with it, and I've seen some pretty cool capture arrays with them where they'll use 19 or 20. There's one of a guy he's doing it was a student, it was a project at a research project where he's acting like a bartender. And I think they only use 19 GoPros, and they're all time synced, and he's taking video. And then they've used either stills to make just 3D scenes, or they've done dynamic 3D reconstructions off of that. It's a data set now. It's an open data set they made at one of these universities. And it's great because they just use 19 GoPros, and it was relatively inexpensive than buying 19 iPhones or 19 DSLRs. And they all came synced. So there's kind of like a fringe camera for fringe benefits of what it can help. But I would say, they're great for creating quick arrays, or I wouldn't call them my go-to camera. So anything you want to add on top of those?
No, I think you touched on it. I think you touched on it.
All right, so the next one's a drone. Everyone thinks these are fun. I have this tiny one. I mean, I think this is 2 models old now. Come out with a new one every other year. This is like the DJI, I don't know. It's a small one. So if you're listening, I'm holding up one of their Mini Pro drones, and it's got an interesting camera on it. So if I pull off this giant clip, it comes with a gimbal, which gives you this nice stabilization, but also on this gimbal, it can turn the camera from horizontal to vertical. So you not only have one orientation, you have 2 orientation options from that camera. And I'll talk about why that's a big pro, but I'd say let's start with the biggest pro of this is you're just giving your camera wings.
Yeah.
So
yeah.
And stabilize. So it's not only is it can go somewhere you can never get to, there's just, unless you get a helicopter or an airplane, you're never going to get the top of a building, things like that at a distance. So drones are perfect. Drones are, what's the other big pro of a drone off the top of your head, Jared? I can think of several.
Oh man, well, okay, yeah. So you can move. A lot of times they have. Well, contrast it back to the smartphone. Usually the drones will have a bigger sensor.
Hmm.
That's nice. Now again, this might be some niche benefit, but drones, especially like DJI, they embed sometimes extra metadata
Hmm.
in the images. And so if you take a photo, yes, there's standard EXIF, but then also there's like I'll call extended EXIF, XMP. There's some other extra tags that DJI embeds in their imagery that can be nice. And so that'll tell you sometimes, well, what was the orientation of the drone? What was the orientation of the gimbal?
Hmm.
And you can use that to to enhance the reconstruction, as added constraints. Um,
You got that. You can use spatial mode in like Colmap, or you leverage the GPS coordinates to
yep,
speed up the initial structure from motion
yep, yep.
reconstruction. So there's some benefits even just having GPS tags that are somewhat correct.
Yeah, yeah. And usually those will be more accurate than like what your smartphone would have given you. Like the
Hmm.
smartphone GPS, is usually within a few meters. Now the drone's GPS is similar, like it's still using the same GPS constellation of satellites, but a lot of times the drone is fusing its inertial sensors, with its understanding of, well, how is it moving through the world to report a
Hmm.
GPS coordinate that's more accurate. It's a
Yeah.
little bit more filtered, um, and
In my
so
recollection of my geospatial days, being up higher, again, it's like you've seen the same
that's true.
satellites, but you're not bouncing anything off a building or anything like that.
That's
So
true.
you have a clearer view of all the satellites. So that, I mean, if you're up there at 200 feet versus at the ground, I've done GPS with the rover rods, and you go right next to a building, and it's going to misread your position just because of bouncing off the building, things like that, the signals. So you have a clear signal up top.
Yeah,
It's a big benefit. And then
yeah,
I'd say like you're saying the XF plus or whatever you want,
yeah.
the enterprise level of these drones will, some of them will even tell you the camera, and they have embedded the camera distortion model, so you don't even
Yep.
have to do that yourself. You calibrate it, they tell you it, they can even undistort them for you if you want.
Yep.
So you get all this great data that you pay
Yep.
for, but if you're doing professional work, it can be really helpful to get a
Yeah.
really quality output. I'd say
And
another.
DJI, like on that note, like I've looked at a few, of at that EXIF, that extended EXIF data, in for some of the DJI drones, and it does look like DJI is doing sort of a per drone calibration. Now, again,
Mhm.
it could be a small sample size. I haven't looked at thousands or hundreds of these things, but at least out of the you know multitude of data sets that I've looked at for a particular drone, it's like each one had a slightly different
Mhm.
set of distortion parameters, and so that is nice. And that it does come with a base set of calibration
Yeah.
parameters.
I'd say another big pro to these is that you again, if we're going up to the enterprise level, so you're doing this for professional work. Enterprise sounds expensive, but they're actually probably in the same price range as just a mirrorless camera. Nowadays,
Yeah.
you can start in the enterprise world in like $3,000, $4,000. That may be higher or lower depending on where you live and things like that. But you can get mechanical shutters then, in which, as we're
Yes.
getting back to that we're getting back to that rolling shutter problem where
Yep.
things get warped. We have a mechanical shutter or a global shutter. I don't know if this is the same or equivalent, but you're basically reading out the whole sensor at once. So you're not giving it time to warp the image as the camera's moving and taking photos. Is that correct? I'm not sure if
Correct.
global and mechanical are the same, but they achieve kind of the same result.
Yeah. Yeah.
It doesn't really matter.
I was gonna say because I think I've seen edge cases where it's like, oh, it's a mechanical shutter, but they're still relying on, like, like the shutter in my DSLR. It's a shutter. It goes up and down. That's a
Hmm.
mechanical shutter.
It's a curtain
Um,
shutter
yeah, it's a
versus like
curtain,
the whatever the one that's
like
it's
an
like
iris.
iris.
Opens up. Versus the curtain.
Yeah.
And so that is a mechanical shutter, but it's backed behind the scenes. It's like, oh, they start and stop the readout of the image intensity in a global ability. Like that when that curtain drops, they can start reading pixels, and then they can raise and stop reading pixels.
You're looking for that global shutter. I know like
Yes.
Red cameras were doing that a long time. I've been doing that for a long time. Some of these higher end professional camera, DSLR mirrorless cameras also do that, where they're reading out the whole sensor at once.
Yeah. And for video, that's hard. Like for video, I don't even know. I haven't looked at this, but yeah, like maybe Red does it, but like for video, having true global readout, I think is hard. But like a lot of times, but with the photos, like if you're taking photos, yes, absolutely.
I think the cinema cameras start to do that, where you're you're not paying 5,000, you're paying 20,000.
That's true.
So
that's true. That's true.
You're probably not buying that for 3D reconstruction. No. I think Red was the cheapest, is why I bring that up. I do know that Sony, don't quote me on this, but one of their mirrorless cameras had, I think it was their A7 Mark III. They had reduced the sensor readout from like 21 milliseconds to 8 milliseconds. And then on the 4, they went back up to like 20, because I think that sensor was really expensive, and they found that people really weren't like willing to want to like that wasn't important to them. Especially because you can compensate for a lot of rolling shutter and software now and things like that. But that was a really expensive sensor they put on that one model of camera, and it eliminated, not completely, but it really reduced that rolling shutter effect by having a quick readout. But it was really expensive for them to put in that camera. So all right, so drones are great. You can fly. I'd say the programmability of them are almost the biggest benefit right there. I can say,
absolutely.
If you have even the cheapest of the, like, I think like for $500, which is not that cheap, but shoot, a drone for $500 won't crash. It'll fly itself practically, and you can tell it to do like just basic programmable things, like a loop around a point of interest, or fly a straight line, things like that. But then as the price goes up even a little bit, you can start to do things like fly a gridded pattern, stop at every photo, or keep moving. Some of these higher end ones, now you can capture it as a lightweight 3D model of an object, and then you'll say, okay, now come up with the optimal flight path, and it'll capture that for 3D reconstruction. So you're taking, that's the greatest thing, is I can say, I want a photo every 70%. I want 70% forward overlap and 70% side overlap on every photo. And it will pretty closely nail that every time. Versus a human, it gets messy. You got to just take a photo, take a step or two, take a photo, just kind of intuitively figure that out, or take a video and then extract a bunch of image frames, which has some plus and minuses to it, taking a video versus an image. So,
I'm so glad you brought up that programmability, because that is such a big benefit to it. We had a whole episode on it, and we touch on it every few episodes, talking about image capture best practices, and talking about, like you just said there, how much overlap when I take a photo, how far should I move, how much overlap should be between those two photos. I want to make sure I don't rotate in place. There's all of these things that you should be thinking about when you're capturing images for 3D reconstruction. But the drone, when you can program its flight pattern, that abstracts all of that away and does it in a nice, consistent manner. And so that's a really great benefit.
Everyone always asks, like, I show like a really cool 3D reconstruction or a really cool Gaussian splat scene, and like, what camera you use? I was like, it's just a drone. That's all that matters. It's because I programmed it, and it was either taking continuous pictures at like 5 miles an hour where you had almost no distortion, or it was paused and taking photos. Whatever it is, I always made sure it was moving really slow and there was no shake. I didn't have a human shaking the camera between shots. And then why I wanted to say it's a big thing about taking a portrait on this as versus always wide. I know a lot of people also like to do, like, say, a building or just something that's kind of vertical in nature versus wide. You can actually be a lot closer to that object. So in a Gaussian splat, you want to get the entirety of the object hopefully in one shot, because if you're seeing, like, it can make some problems. In photogrammetry, not as big a deal, but let's say I'm trying to do something that's more vertical than wide. If I put in portrait, the arc in which I have to fly around it can be a lot closer to capture the whole thing in one shot. Then if it's wide, I have to get much further back because the field of view is now more vertical than wide, and so
Yep.
that can make a huge difference right there as well. So there's a little bit more flexibility now with these. I'm noticing more and more of them have these like turning gimbals, or even now like the the Mavic Pro 3, whatever they're like starter enterprise one, will have like a telephoto and an ultra wide. They have more than one lens on there, like an iPhone
Yeah.
or a Samsung, where they have more than one. So you have all these flexibility for what you're trying to do. So, yeah.
Yeah. They're
So they're
very
good.
powerful.
They're
Very
good
powerful
for capturing
platforms.
big scenes, buildings, things you can't get around. I'd say.
Yeah.
I'd say there's never a bad day buying a drone if you want to get into it, because you can also have fun with them. But
Yeah.
also know that like you can't just fly them anywhere, so you have to know your local laws. Yes. All right, so I'm gonna spend. So we've almost been here on an hour, so let's just speed through some of these special cameras, because I don't think people use them as much. But I have one on my desk here. It's a 360 camera. They stopped making this one. I liked it because it had a 1-inch sensor, which was a big deal. But there's new ones like the X5. That this is an Insta. If you're listening, it's an Insta 360 RS 1-inch 360 edition. I don't know. It's their 1-inch sensor one. They stopped making it, but their X5 now like is getting better results with the smaller sensor and just computational photography. And so you're getting a 360 image, which they can stitch together the two spherical
The two
lenses
hemispheres and
yeah. And so
Yeah.
those are really like the big pro to this is I can capture an area with a lot less imagery. So the time to capture a scene is really reduced. But I'm in the picture. I can put it on a helmet and put myself underneath it. If you're listening, I'm actually putting it like on top of my head. I can put it on I have like a selfie stick, which disappears in the imagery, but I'm still in it. So you either have to mask yourself out. So by capturing everything, you're in it. Or you have to like dangle this thing from a drone or put it on a robot. But then come on. I like them. I love playing with one. I found out if you're outside, it's hard to get a lot of parallax if everything's really far. So you got to really move, but to get that parallax. But if I'm in like a room, they're really good. So I think that's where their excel is in like even a large warehouse room where there's a lot of things that are relatively close. But if you're outside, everything's really far. You got to make a lot further movement than you think to get a parallax shot, which we all talked about in the last episode is kind of paramount.
Yep. No, definitely. I'll harp on that too. I just think like, the greatest strength for me, I see it is being able to capture so much imagery in a single pass. And then even more so, like what you said, indoors, say in constrained environments where I'm trying to capture, a limited space, a constrained environment where it's hard for me to move around, move side to side, rotate around. It's very easy. If I have just a normal, 60-degree field of view, wide angle camera, I've got to do a lot of arcs back and forth and move in and out to capture all the surfaces of that room or that environment or that tight quarters. Whereas with that 360 camera, just you get in, you get out, and it's seen everything that was there.
Yeah. And then I run into sun issues. So if I'm outside and it's sunny, you get sun flare. It'll capture all the like little smudges or anything on that lens. The lens is really exposed.
Yeah.
So they're finicky, but they're cool because they're kind of like your shortcut to fast capture. You have to the images are all super distorted. So not most 3D reconstruction won't take them natively. You gotta like cube map them, or there's different techniques.
There's different techniques. Like there are some algorithms. I think OpenMVG supports processing spherical images or that 360 image natively. They could do that through algorithms, or like you said there, try to cube map it. Rendering pinhole style camera. Rendering normal looking photos from that 360 footage.
Then you're going through a lot of steps. You got these. You're like stitching together distorted images into, which is going to have some inherent problems, and then you're going to then project pinhole flat 2D images out of a 360. So you can run into some problems. So I want to put that out there. Play with them. I thought I had one more thing I wanted to add on top of these that were really cool. It's escaping me, but there. Yeah. Oh yes. Also, this is a 6K camera, 6K video. Sounds like a lot of pixels, right? I mean, you're taking 4K on a normal camera, and it takes a 21 megapixel still. Sounds like a lot of pixels. But what you don't realize is that you're stretching 21 megapixel images across 360-degree field of view versus, a very small field of view. So your pixel density is a lot smaller too. So
Yep.
if you're doing video specifically on these, you're probably not going to get a really high resolution output, which is fine. I've found that it works really good to get point clouds of things where I don't care about getting perfect textures, but it will not look great if you're just trying to get, good texturing and things like that. All right, so the next one is I had fisheye cameras, but we already talked about that. You can get just fisheye cameras, which are really like the GoPros, things like that. They have a huge field of view. I think they're really useful because you can put them on robots, and robots need them to see. And there's like these cool SLAM algorithms that use that wide field of view. So if they're trying to figure out where they are as they're moving around, those are great. I would love to do get a robotics researcher on here and talk about that sort of camera system for sensing.
Oh, totally. Yeah, like the task of perception, like what setup, what camera system, what algorithms you're doing for real-time robotic perception versus what we've kind of been talking about, which is more photogrammetry, 3D reconstruction. Yeah, different things. That would be fun.
Okay, I have another one here. If you can't see on the screen, it's an OAK-D light sensor. So it's the size of just like, I don't know, slightly bigger than a Kit Kat bar, but not even like like one of the bars within a Kit Kat candy bar. Like one of the break me off parts. It's probably twice as wide, maybe. And it's got a left and right camera. It's hard to see in here. It's got a left and right camera, and then a middle camera. So the middle camera, I believe, is a 4K RGB camera, and then the left and right cameras is a stereo pair. So it already knows, like in the camera, how far those are, and they are black and white. There's no color out of those, but I get an RGBD output from this. So I get red, blue, green, and a depth. But depth up to a certain distance, because if we've talked that there's like a baseline, and if this was to say 3 times as wide, it could probably get further back, but it can't. It's like your eyes. You only have depth perception to a certain point, and then at that point, you really just know depth based off of your brainness, knowing what things look like far and wide. So is this a stereo camera or an RGBD camera? I don't know. I didn't know what to put this in. Because I think some RGBD cameras have an actual active sensor, like an iPhone RGBD mode is like you have a camera and then you have the LiDAR, and so you can get an RGBD, I guess an image, that's an image. So this is a stereo camera, which is really cool. And this one even has a heat sink on the back because it's got an onboard compute. So it can do onboard image recognition and OCR, all those different things it can do like right on here. So then it's sending like the post-process data to it. So these are really cool. It's really special. So the big pro of something like this is, again, like robotics. Or maybe it's attached to robotic arm sensing and it needs to know something relatively close for grasping objects and detecting what the object is. At this point, you're probably a computer vision researcher or a robotics engineer, and you're going to be diving in this. This one connects over. I'm not trying to sell these, but I promise this one is a USB-C. Some of these will be PoE, so they're power over Ethernet. So there's just different things you can do with these kind of specialized cameras, and you can just put them on things, and it's so small. I mean, it's crazy. It does have a computer on it, I guess, but it's not like a Raspberry Pi on board where I can put an operating system on it. So, Jared, do you have any thoughts on those kind of cameras? What you like them for?
I was gonna say, to me, like I liked what you said about the robotics applications. To me, coming with some of the research background, sensors like that accelerate research. And so whenever the Microsoft Kinect, Xbox Kinect sensor came out, great, research labs were buying those things up because now instead of having to spend time implementing stereo depth estimation algorithms based on imagery, you can just buy a single off-the-shelf sensor that gives you depth for free. And now as a researcher, we can spend our time figuring out, well, assuming we have depth, now what do we do with it? And so you can kind of skip over all of these algorithmic challenges and just start with depth for free and run with it. And so it's really nice for that research space and just being able to get data for free and run with it.
I've noticed in a lot of research. I love to dive into research papers, but I've noticed a lot of them will be saying like start with RGBD data provided, and it came from a sensor like this. Or I've noticed they're now. Again, we can cheat our way into depth. So they're using like these depth anything models. So they're using machine learning to just estimate the depth of the scene within a bunch of images or video.
Yep.
So it's like, oh, all right. So you're skipping the structure for motion to get the depth in these images. That's fine with me. But I notice they're not coming usually from these. They have them. And I guess like you said, the Kinect sensor, the Intel RealSense sensor, those have more of an active sensor and a camera pair. So, you get all kinds of different ways, I guess, to get depth.
Yeah, different depth sensing technologies, yeah.
So they're really useful. I like that for research. I definitely see a lot of them. Or you're not buying one of these to do photogrammetry. You're buying one of these to know the depth of a scene and sense. Machine perception, I think, is more of what we're talking about here.
Yep.
Okay, so that's what they're good for. The big cons is, I'd say the big cons on these guys is usually they're lower resolution. They're really single use. You probably buying this because you know what you're going to do with it. I bought this off a Kickstarter campaign, and I was just wanted to know how they worked. And so this one was, I think, $72 on Kickstarter plus shipping years ago. But you can buy these. These are cheap. You can still buy one of these for under $200, or I think they have different brands for like $100. So you usually probably have multiple ones of these for different things. Okay, so I have two more cameras. One, we talked about event cameras. I think that was. I don't even know if we want to go over that again, Jared. That was really. So tell us again what an event camera is.
Yeah, so event camera is totally different than. Well, it's totally different than other cameras. So normally, when we've been talking about cameras up until this point, we're talking about a sensor, a lens, and then the output you get from that is a color image. A 2D grid of pixels that have color information.
Mm-hmm.
And we as humans, we love that. But what those cameras, these cameras are kind of bad at is perceiving really fast motion, really fast change. It's like, sure, you can say, I can set my shutter speed to 1,000th of an image. Great. But what if what I'm trying to observe is moving at a 10,000th of a second or 100,000th of a second, really, really fast. And so that's where event cameras start to come into play. And so event cameras are still as a sensor, a lens. I'm looking at a grid of locations, in front of the camera. But what you get is not color, but you get changes in intensity. Mm-hmm. So when a pixel changes enough in terms of, it was black and now it's gray, or it was gray and now it's white, you get an event. That pixel all of a sudden turns from off to on. And so your camera gives you this asynchronous stream of pixels turning on and off, telling you where motion's occurring, and maybe how much. You don't know how much motion. You just know for that pixel how much did its intensity change, or that if it changed. So it's very different. You don't get any pretty picture to look at. It's more like robotics style sensor. It tells you which pixels are moving in the image, and it sort of allows a robot to respond really rapidly to what it's seeing.
Okay, so those are really special. I'm guessing they're
really special.
Probably even less likely you have one of those than one of the
Yeah. You have to be a researcher to have your hands on one of those.
Okay, and I do apologize if you're hearing my cat meowing in the background. And then so I have one last camera. It is I'm taking two types of cameras in one, but they're kind of achieving the same thing. I had thermal and multispectral. So what they're doing is they're not looking purely at the RGB spectrum of light in which our human eye can perceive, and it's looking at ultraviolet, it's looking at red edge. There's all these different things. Okay, I have seen reconstruction of things. I've seen, I think, a Nerf once made with thermal cameras. It is possible, but it really, to me, doesn't really make sense to, but maybe I'm mistaken what they're really used for. You ever see those really used much in 3D reconstruction, or?
Not per se, because a lot of times I think what you said, like if I have a thermal camera a lot of your challenges there are just the resolution of the data you're going to get from it. I think
Mm-hmm.
even just like, either hardware or a lot of times just regulations limit the resolution of the imagery that
Interesting.
you can get from a thermal camera. And so you're operating on 320 by 240, so less than a million pixels, less than a megapixel. Um, for any sort of thermal imagery you're getting. Compared to normal visible light, RGB, yeah, you've got multi-megapixel,
Yeah.
tens of megapixels to work with, and so it's just that's easier data to operate with.
And I think too, a lot of times like thermal cameras, you really need to know what you're doing when you get into those. You hopefully consult someone who knows, because like thermal cameras are going to see a thermal range and they have a sensitivity to change. So like a pixel isn't necessarily like a degree of change in temperature or something. It's got some sort of range threshold. So like a lot of times we won't even pick up things unless it's over a certain temperature or things like that. And with Ken, coming from a geography background. I remember at my university days, we looked at multi and hyperspectral imagery from satellites, things like that,
Yep.
and drone, or probably back then it wasn't drones. So it was probably like mounted to an airplane. But that's cool because they can stitch together a bunch of images and make orthomosaics of spectrums of light, and then be able to know perhaps the vegetation health of something. If something is dying, you would even know what specific plant species things were off of, based off of the color or the reflectance of different bandwidth of light coming off of them that you couldn't necessarily see, but you would get a signature because everything had a unique signature. So you could say, oh, this is all grassland and there's the deciduous trees over here, and even what type of trees and types of grass. So it's more, again, in getting your academics and science and things like that. But I'm not
Yeah.
seeing 3D reconstruction off those again, but I thought I'd mention them. They're quite interesting cameras, and yeah, they can do some cool things. And there's an economy of scale too. They're not making a lot, so they're really expensive. So, it's expensive probably to manufacture them when you're not making millions of them at scale.
Yeah.
So,
Yeah.
all right. I think we covered all the major cameras. I'm sure there's some cameras someone's going to comment on these episodes and say, but what about this camera or what about that camera? But I think that covers it all. Well, thanks, Jared, for jumping on this episode. And
Oh, absolutely.
I would say, okay, one thing I didn't have here, I had on my notes. I said, so at the end of the day, when you're choosing which camera to use, I'd say if you're just new to the 3D reconstruction journey, start out with the camera you already own. Hopefully, it's already a smartphone, because that one, again, I use the right words. That one is low barrier to entry to get good enough images. If you're already taking professional photography for fun and you want to move up into 3D reconstruction of like meshes or Gaussian splats, something like that, I highly suggest start their smartphone, figure out that, then move to that camera, because you're just adding layers of complexity, even if you already know how to use those type of cameras.
Yep.
And then drones, if you have a drone, play around with the capture patterns first. I think I've only rarely have I ever freeform flown something and captured images. I typically just stick to the pre-programmed flight paths. And then the rest of the cameras, yeah, you're probably a researcher at that point, or 360 cameras. There's great YouTube resources. If you go look on YouTube on how to map things with those, you'll find out there's only a handful of videos, but they're all very useful. So anything you want to add on top of that? That's typically my...
No, and that's great advice. The only thing I'm just coming back to now, maybe I could have said this at the beginning, but it's like, well, what is a camera? At the end of the day, we've talked about all of these things, and a camera is just an angular light sensor. It's telling you in which, from this camera's perspective, in this direction, I saw this color of light, or this frequency distribution, of light coming to me. And so all these different cameras are just different ways to map that hemisphere or that 360 degrees or whatever subset of viewing directions it is, and mapping that down to a set of pixels that then we can use and represent later. So
Exactly. It's sometimes it's less about the camera and just type, and it's just learning to use what you have.
Yep.
The best out of
But
it.
I love your advice. Use the camera you have, because it most likely is a smartphone, and that's going to get you pretty far.
If you've bought a smartphone in the last 5 years, you're gonna have a fantastic camera for getting a lot done. So,
Yep.
I didn't mention this too. If you do have a mirrorless camera, I always tell people to opt for at least for Gaussian splats, but also I know for photogrammetry, you want like a wide one. You you want a 14 millimeter to 20 millimeter, so you're getting this nice field of view. If you're trying to get around with like a 200 millimeter lens, you don't get much in that camera, so you end up having to take much more photos. So I guess we didn't. There's some pros and cons to different lens choices and things, but yeah, wide view, sharp images, even exposure. Use the camera you have. There you go.
There you go.
All right. Well, thanks for joining us on this episode. Hopefully our next episode, I'm looking to get some people on this. So again, if you're listening to this far to this very end of this, and there's someone you know in the world of 3D reconstruction and computer vision, which you think would be a good guest, we're gonna start reaching out to guests because I think we need to start expanding back out to getting some experts. We did mention OpenMVG. We even had the inventor of that, the creator of that, Pierre Moulin, on here in the past. So we've had some really good people bringing different perspectives, and I'm looking forward to bringing people on again like that. So anyways, well, thanks for joining me, Jared, and I'll see you in the next episode.
Thanks, Jonathan.